Hello class, it's another digital literacy lesson. So in this lesson we'll be examining internet and communication. So as a techie, you need to understand how the internet works, how we communicate on the internet. You need to understand that. All right. Now before we dive in, I would like to ask a question, right? So before we go into the slides, have you ever wondered what it takes to communicate on the internet? Have you ever wondered what are the underlying technologies, what are the stuffs that are combined together that makes the internet works? We're going to unravel that in the course of this lesson. Alright. Now, to understand how the web works, there are some important terms you should be familiar with. The web. Now, the web is like a huge library filled with books, right? Like a huge library of books, and each of these books are known as websites. So you access websites on the web. The websites are located on the web. Now each website is like a book with pages, right? Because each website has pages. They have pages. So like if you go to Facebook, you have the home page, you have the profile, blah blah blah. So there are different pages on a website. Now a website with just one page is just a web page, right? Just a web page. Like Google, for example, it has just one web page. So Google is much more complex. Actually, it's a search engine. Alright. So you use a browser to locate websites on the internet. So your browser is just like a librarian that helps you find books, right? Now the web is the library. Web pages are the website is a book on the library, or websites are books on the library called web, while the browser is like the librarian that helps you to find different books, right? So your Chrome, your Firefox, your Edge, Microsoft Edge, and so on, they help you to find websites on the web. Without them, you will not be able to find any website. So the web pages are the pages of the books. Alright. So what's the web app? Now a web app is quite different from a website, right? We'll compare them in the next slide. Now a web app is like an interactive shop inside the library. Now a website is just a book that you can just flip open. Now if you take a look at a book now, right? A storybook and maybe a tablet or something simpler, maybe just a game, a PSP game, this portable PlayStation. Now you see that the book, you just flip the pages open, is static. The contents do not change. But when you use a PlayStation now, a portable PlayStation, PSP, you notice that the stuffs are changing, right? Even there are all these brick games. I don't know if you guys know brick games. Those brick games are this rectangular stuff that you play different games, but those games are made of bricks, stuff like that. So that's more interactive. It's interactive unlike a book, right? Instead of just reading, in a web app, you can do things like shop, like Jumia, like Gigi, AliExpress, and so on. You can shop on it, you can chat, you can book a flight, you can watch videos. Examples are Gmail, YouTube, Google Docs, Jumia.com. YouTube, you watch videos. Gmail, you can send mails. Google Docs is the Google version of Microsoft Word. So Google has its own word processing software, which is Google Docs. You might just take a look at that in the course of this lesson. Right. Now, websites and web app. You should understand the difference between website and web app, and we have already emphasized that. We said websites they have static content. For example, a news site. Let's say you want to have a website just to display your products, just to let people know about you, be aware about you. That would just be a website, a static website. Now static websites are usually just front end only, right? They have nothing going on behind the scene, because you just need to access them and see things. Now web apps are more interactive and dynamic, like Gmail, Facebook. Now web apps, you usually create account on them and log in, right? They usually require you to create accounts, log in, right? They have a database. They have database. That's where your information is stored as a user. Your informations are stored there. What you order, what you are buying, whatever, those ones are stored there. So native apps, you need to understand native apps too. Now a native app is like a store you build in your own home. Now native apps are actually installed on your phone or your computer, right? So instead of accessing them on the internet, web apps on the other hand, you access them on the internet, like facebook.com. now that one is a web app, but when you install the Facebook app from Play Store or Apple Store or Microsoft Store, that is a native app. It runs on your device by default, and you can even access some of them without internet connection, but you can't access web apps without internet connection. But you can access some native apps without internet connection. For instance, games. Now games, you don't need to connect to the internet to access games. So web native apps are installed directly on your device, and they can use special features of your phone, like your camera, your microphone, your contacts, your GPS, your notifications. So native apps can use this. Example is WhatsApp on your phone, and you know a lot of them. You have your Chrome, even your Chrome on your phone. That's a native app. The internet. Now the internet is just a global connection, a global a network of networks. Now what do I mean by that? Now in your home, if you have your PC, your headphone, your printer, you connect them together. That's a network on its own, right? A network is just connection of two or more entities. So when you connect those things together, when you connect those devices together at home, now if you want to access the internet, you have to connect to a bigger network, because there are other networks in other homes, in offices. So now when you connect your own to the internet, you will see, if you take a look at this diagram, this picture rather, you will see different points, different joinings, right? Different joinings, meaning that a global network of networks. That's just the internet. So the internet is just like the roads and highways that connect all the cities in the world. The web is just one of the big cities on those roads, right? So the web is just one of the big cities on the road. Like, okay, all right, so let's go on. Now submarine cables. Now data travels across different locations through submarine cables. These submarine cables are just high capacity fiber optic cables laid on the ocean floor. They pass under the sea. Now these cables are the backbone of international internet connectivity. They carry over 95% of the world's data traffic between continents. So we depend largely on these submarine cables for data transmission. Right? Let me show you something quickly. If you type on your browser, submarine cable map, you will see, no, this is not what I want. Just type submarine cable. Okay, yeah, this is what I was looking for. Submarine cable max. You type submarine cable max, you see something like this. This is just like the FAQ. I want the home page. Okay, submarine cable map. I accessed one earlier. Okay. So you see, these are the wires that transmit data across the internet, right? Across different locations in the world. So these are the cables. These are like points where these cables are terminated or joined. Alright, so you can explore that later on. Now, if you would like to know more about it, you could search on your search engine. You could go to your browser, search for submarine cable marks. How do they work? If you like to know how they work, you can use this link as when this slide is dropped on the group. You can use this link in the slide to check more. All right, so now we know that satellite exists, but I know you might have wondered, why can't we use satellites for communication? Now, satellites exist, but they account for less than 5% of internet traffic, of international traffic. Why? Because submarine cables offer faster speeds, right? Submarine cables offer faster speeds than the satellites. So there's lower latency. Now, latency is just the delay in the arrival of packets. Now, data is actually transmitted in packets. So there's in satellites now, I mean cable maps now, they have lower latency, meaning that this latency is just the delay in the transmission of data across a network from the source to the destination. That's what latency is. So they have lower latency, meaning that lower delays, right? They have higher bandwidth. Bandwidth is just a measure of maybe how many bytes per second or megabytes per second that can be transmitted across the network. Then they have greater reliability. They are more reliable than the satellites, right? They are more now, satellites can crash or stuff like that. They can be shot, they can be targeted and hacked and stuff like that. They can be hacked actually. So clients. Now you need to understand client-server model. We'll still talk about this as the lesson goes on. Now, when you want to access the internet, the client is you, right? Now, okay, listen now. When you're at a shop and you want to buy something, the client is you, the customer, right? Now, just like that, when you want to access the internet too, the client is your device, right? Your device which wants to access the internet. That's your device. You see now, the client's phone, either a smartphone, a PC, or a desktop. Then this is the internet. Then this is the server. Now the server is just like a shop or restaurant that gives you what you ask for. Like if you walk into a pizza shop now, the server is just the those that will respond to you. Now you, the client, you search, you ask for something, and then the server will respond to you. Now your device is the client. There's another device. Now there's what is known as a server. It's not really it's actually a computer too, right? But it's located at a specific location. Now this computer is connected to the internet 24/7. It is online 24/7. So that whenever a user wants to access information at any time, the server has to respond, right? So the server is online 24/7. Now domain name system, DNS or domain name system. Now your DNS is like the phone book, of the internet. Now most of the time you don't remember people's phone numbers, right? It is easier to remember people's names unlike their phone numbers, right? It is easier to remember people's names. So now each of the devices on the internet has a unique address called the IP address. We'll talk about that in the next slide. Now these addresses can be simplified using what we call domain name. Now Google address actually now this is 142.250.190.78. it will not be easy. You may not memorize this easily, but easily you can memorize google.com. So google.com is the domain name of Google, while this is the IP address. So it's like a phone book. This is the phone number, this is the name of the person, right? So the DNS, the domain name system, helps you to find the correct IP address, because if you want to search on the internet now, your internet does not your computer does not understand domain name, right? It only understands this IP address, but you understand you are used to your domain name, more than the IP address. So you type the domain name, and this domain name system will help you find the IP address for it, so that it can be transmitted. It can be transferred to the appropriate quarters for processing. Now the IP address is like a house address. That's what is used to locate each house, right? So it is used to locate devices, websites on the internet. Now we have private and public IP address. Now a public IP address is a globally unique identifier assigned by your internet service provider (ISP) to your network to allow devices to connect to the internet. And we also have a private one. Now a private IP address is just assigned by your router. Let's say you connect your device to Wi-Fi networks. Now your router will assign IP addresses to each of the devices connected to the network. Now there's a way you can check your IP address, especially your private IP address rather. That's your computer's IP address. If you are connected to a network, you can just go to your start menu and type cmd, and you open your cmd. So on the cmd now, you can type ipconfig/all. No, I'm supposed to open as administrator. Sorry, cmd. Let me run it as administrator. Okay, ipconfig/all. I think the issue would be that because I'm not connected to a network. So whenever you are connected to a network, you can use that. To find the private IP address. We'll talk about how to locate the public IP address of your device as we go on. Now ISP, Internet Service Provider. Now the ISP is like your a bus company or road builder that gives you access to the roads, right? Now your ISP is your networks like MTN, Airtel, Glo, without which you cannot connect to the internet, right? You cannot connect to the internet without these internet service providers. Now whenever you are to be given access to the internet, you have to pay something like, the internet is like I'm coming. There's something that's keeping my mind. Okay. Now the internet is like the world, right? Just like the physical world we have now, we have the virtual world. So the internet is like the virtual world. Now there are locations on it. There are buildings. There are houses on it, right? Now if you want to use a space on the internet, if you want to like go somewhere and stay there for some time, now in the physical world you need to like pay something like called the rent, right? If you want to lodge at a hotel, you pay for it. Now just like that also, you have to pay to your internet service provider ISP for using the internet, right? You have to pay like a kind of rent fee too. So that's the subscription you do on your networks, right? That's the subscription you do on your SIM stuff now, and that's what we call data subscription. So now depending on how much you can afford, that's the higher you can afford, the longer you can stay on the internet. Now I want to give the website. Now I want to give you a simple analogy. Now a website, just like we have physical locations called sites, right? You can say, okay, your new site, your house. Now websites are also like they are just like sites on the internet too. I think that's why we call it a website. They are sites on the web. That's why we call it a website. All right. Now this is how the web works. This is how whenever you want to locate information on the internet, this is how it works. So your client, your device, which is like the client. My battery is running low, but never mind, we'll complete this lesson. So your device sends a request, right? So when you type www. For instance, example.com, this does not exist, it's just an example. If you type www.example.com in a browser and you press enter, your device, which is called the client, needs to know the exact IP address of the server where the website is stored. For instance, this. So So you need to know the IP address where this server is stored. Now your internet service provider will give you access to the internet if you have paid to them, if you have subscribed. They give you access to internet and they assign IP address to your own device. Now computers don't understand domain name, like I've said earlier, so they use IP address to locate it. So it is the domain name server that will convert the domain name that you entered into IP address. Then this IP address, when the IP address of the server has been identified, your request will now travel through routers and switches across multiple networks to find the web server. Okay. All right. So once that is done, sorry, there was a final part I didn't put. Now once that is done, the information will now be sent back to your computer. Your computer will now, your web browser will now organize it. Now the information will be sent as files. The address of the server will be sent as files, right? As maybe HTML, CSS, JavaScript files. It is now your browser that will organize it again and display it as a web page, as a website rather, or a web app. So whenever you are browsing, remember to use HTTPS. I will explain that as we enter our web browser to use it. So HTTPS is actually HTTP secured. HTTP is hypertext transfer protocol. That's what we use for transferring files on the internet. That's what we use. That's like the protocol for the internet. Now the S after it means secured. So HTTPS is secure, and HTTP is not secured. Sometimes when you try to access websites with HTTP, the internet will tell you that this is not secured, right? Now avoid clicking suspicious links. We will still discuss this I think in our next lesson or so. Avoid clicking suspicious links. There are some links that are suspicious, like whenever you are accessing your internet, you see some ads that your phone is has virus and stuff like that. You should do not click on suspicious links. It's very dangerous. You could install malware on your computer or your device unknowingly. Use strong passwords. Use strong passwords whenever you are sharing your devices, or even for all your accounts online. Use strong passwords. Now what's a strong password? A strong password is just a password. Now it's a password that has at least eight characters long. Is strong. It's 8 characters long, has uppercase and lowercase letters, has numbers, and has at least a special character. So you can even ask online that what's a strong password, or you can even check how strong your password is. You can see check online password strength checker. So you can enter your password that you are using. If I enter maybe Lawrence, you see very weak. But if I enter, let me show it so that you see. If I enter Lawrence 1 2 3 4, it's still very weak. Let me enter something random. I'm coming now. If I enter at Lawrence 1 2 3 4 5, it is still very weak, probably because of this. Now one of the tips about using password is that do not use your names, right? It is risky because it is easy to crack for attackers. It is easy to crack. In fact, see, they say here that the time taken to crack your password will be 0.38 seconds. Let me now use something like a random text. You see, very strong. FJK 2345. Take note of the time taken to crack. If I use these letters only, say it takes 51 years. If I add numbers and if I add a special symbol, very strong. It takes 9 million years to hack, even for the world's fastest computer, right? It takes 9 million years. So you should use strong passwords. You can test your password with this to see whether it is easy to hack. And you can use tools to generate random password generator. You can use tools to create